Hello students, here's the review for the test for unit 11. And so the only thing is that in here I'm going to ask you to find not only the volume but also the surface area. And so first I'm going to start with the volume. The volume for this first figure is, there are two different ways to do it, which is the area of the base, which is noted by a capital B, times the height. The other one is volume is equals to length times width times height. And that's only for rectangular prisms, where you just multiply the length times the width times the height. And so in here, since we learned it this way, well, in here is just 10 times 10 times 10. And 10 times 10 is 100 times 10, which is equals to 1,000 cubic centimeters. Okay, that's the volume. The other way is to find the area of the base, and the base is 10 times 10, is 10 times 10, and that is multiplied by the height of the rectangular prism, which is also 10. So if you notice, it's going to be the same thing. 10 times 10 is 100 times 10, which is 1,000. And again, remember that volume is always cubic because it's three-dimensional. And that's it. For the surface area is going to be two bases. So basically we're going to find the area of the base, and we have two because we have the top and the bottom base, plus the lateral area, el área lateral, okay, which is the sides. I don't know if you remember that we undid that. And so the base is the area of the base, which is 10 times 10, or they actually have the area of the base of a square or rectangle is base times height. So that's where that comes, okay? So it's going to be two of them because we have the bottom and the top. So 2 times 10 times 10. So the area of the base is 10 times 10, but we have two of those faces, and that's why we have that. In the lateral area, I don't know if you remember, but it's the perimeter of the base times the height of the prism. And so this is going to be 2 times 10 times 10 is 100. The perimeter is, if we have 10 and 10, the perimeter is adding all four sides of that base. And so it's going to be 10 plus 10. So let me do the perimeter on the side with a different color. The perimeter is equals to 10 plus 10 plus 10 plus 10, which is equals to 40 centimeters. Okay, so the perimeter is 40 times the height, which is 10. 10, and so the surface area is 2 times 100 is 200, 40 times 10 is 400, and this is the area of the two bases, the bottom and the top one, and this is the area for, like, if you were to paint on the sides of that rectangular prism or that box, all four sides. Okay, and so 200 plus 400 is 600. Area, it doesn't matter if it's surface area or just area of a polygon, is going to be squared, so it's going to be square centimeters. Okay, for the second one, remember, if it has a point for the volume, you're going to divide by 3, and we already saw the videos of how you pour it into a prism, and it comes out to be 3 of these makes one rectangular prism, which is the video that we saw with corn, I think, popcorn. So the volume here is going to be the area of the base, times the height of the prism, of the pyramid, divided by 3. That's for the volume. The area of the base, since it's a square, because it has 6 and 6, the area of the base is 6 times 6. And the height is perpendicular to that base, okay? So it's gonna be 4 centimeters and divided by 3. So that volume is 6 times 6 is 36 times 4 divided by 3. And so 4 times 36 is, 4 times 6 is 24, carry 2, 3 times 4 is 12, 14, and divide by 3. And so the volume, the 3 goes into 14 4 times, and you have 2 left. 3 goes into 24 8 times, and so that's 48. Volume is cubic, so cubic centimeters. Okay. For the surface area, you're gonna find it's like you're painting each face, and we have the base, which is a square, and then we have 4 triangles. So it's gonna be the area of the base only once, because we only have one base, plus 4 triangles. Okay, and you can just put a triangle in there if you and we'll put the formula in a minute. So the base is base times height, or side by side, or side square, they say. For the, it's up to you how you want to put it. You can put base times height, plus 4 times, or 4 multiplied by base times height divided by 2. This alone, this inside of this parentheses, that's the formula for the area of one triangle. But we have 4 of them, so that's why we multiply by 4. So side times side is 6 times 6, or 6 square, is the same thing, plus 4 times the base of the triangle is 6, because this is 6, this is 6, this is 6, 6. So the base is 6. The height of the triangle, they give it to us in here. Remember that maybe you might be asked to do the a squared plus b squared equals c squared if they don't give you this. So 6 times 6 and divided by 2, because the formula asks for that. 6 times 6 is 36. In here we just bring down the 4. 6 times 6 is 36 divided by 2. We are going to divide, just bring this down, bring the 4 down, divide 36 by 2, which is 18. Bring down the 36. We multiply 4 times 18. 4 times 8 is 32, carry 3. 4 times 1 is 4, and 3 is 7. And finally, you add those, so it's going to be 108. For area, it's going to be square centimeters, okay? Remember to put the unit of measurement. So the volume for this one is going to be, volume is equals to the area of the base times the height. And remember, ouch, 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 if it has a point, you divide by 3. And also remember that sometimes you see this formula as 1/3 of base times height. Remember that capital B stands for the area of the base. So the area of the base, since it's a circle, is going to be pi r squared. The height of the cone is 4, but we're just going to put h right now, divided by 3. pi is 3.14. Radius is half of this because this is the diameter, which is 6. So the radius is 3 square times the height, which is 4, divided by 3. And so we have 3.14 times 3 square is 9 times 4 divided by 3. In here, I'm just going to go sideways, is 3.14 times 4 times 9 is 36 divided by 3. And so we put 3.14 times 36 divided by 3, and so it's the volume is 37.68. 37.68. Remember, volume is always cubed, so cubic centimeters. And that's the volume. Surface area is equals to the area of the base plus the lateral area, meaning on the side, or if you're talking about a cone, the cone part. So the base is pi r square. The lateral area is a little bit different than the others, but it's not that hard. It's pi times 1 radius only, and times they call it the slanted side, but they represent it with an L. So the slanted side, it's not the height, it's actually this height that it's kind of tilted, okay? So pi is 3.14 times the radius, which we already said is 3, square that, plus 3.14 times the radius, which is 3, times the slanted side, which is 5. And so this is 3.14 times 3 square is 9, because it's 3 times 3, plus 3.14 times 3 times 5 is 15, and 9, that's where we go to the calculator. So 3.14 times 9 is equals to 28.26. And since we're using a scientific calculator, you can actually put this 3.14 times 9 plus 3.14 times 15. And this will calculate, the calculator will do it for us, where they will multiply this first, and then add this together. So 3.14, I'm just going to show you so that we have the next step, times 15 is equals to 47.1. Finally, we add this 2, so 47.1 plus 28.26, and the answer is, for the surface area, is 75.36. Surface area is always square, so squared centimeters. Okay, let me show you that you can input this in the calculator. You can even go back to this, but I'm just gonna go this up to here and put that in the calculator. It should come out to 75.36. So 3.14 times 9 plus 3.14 times 15, and it automatically goes to 75.36 square centimeters. In here, for the volume, it's similar to the cone, except that it doesn't have a point. You don't divide by 3. It's just the area of the base times the height. See how they are related? So the volume is equals to base, meaning the area of the base, times the height. The area of the base is a circle, so it's going to be pi r square times the height. Pi is 3.14. Radius is 4. In here we don't have to divide by 2, so 4 square. The height is 7. 3.14 times 4 square is 4 times 4, which is 16. And then times 7. 3.14 times, again, you probably do in the calculator here, and it'll take you to the answer, but I'm doing step by step in case you are asked to do that. So 7 times 16 is equals to 112. 112 times 3.14, and it gives me the volume of 351.68. Volume is cubic, so cubic centimeters. Remember, we don't divide by 3 in here because it doesn't have a point. Only cones and pyramids are being divided by 3. Surface area. For the surface area, you're going to find 2 bases, the 2 circles at the bottom and the top. So it's 2 bases. So meaning find the area of the base, multiply it by 2 because it's 2 of the same circle, plus the lateral area. That is like if you're looking at a can of corn, there is paper rolled around it. The lateral area is the paper. If you take it out and unfold it, it becomes a square or rectangle, depending on the length and height. And so for the base, we have a circle, which is 2 of those. So it's pi r squared multiplied by 2 because it's 2 of those bases, plus the lateral area. The base, when you open the paper that rolls around the can, is the circumference. So circumference times the height of this cylinder. Okay, this is a cylinder. And so that's what you're going to have. Circumference times the height. And let me write it or develop it a little bit more. So 2 times pi r squared plus the circumference is diameter times pi and times the height. Okay, we are not given the circumference, I mean the diameter here, but we can figure it out because it's always double the radius. So it's going to be 2 times 3.14 times, we cannot have a parenthesis inside of another parenthesis, so this becomes a bracket, times the radius. This one we have the radius square. Okay, so we just substitute the pi by 3.14, the radius by 4, and square, plus the diameter. If the radius is 4, then the diameter is going to be 8. Pi is going to be 3.14, and the height is 7. Okay, so in here we're going to multiply 2 times 3.14. 4 squared is 16 because it's 4 times 4. In here you can multiply this times this first, or I prefer to do the whole numbers first because multiplication is commutative and associative. So 7 times 8 is 56, and just bring down the 3.14. Then I also prefer in here, even if it's outside, you can also multiply this, and it's not distributive property because distributive property is only when you have a plus or minus in the middle of the parentheses. Okay, so in here I'm multiplying 2 times 3.14 times 16, but I prefer to multiply these 2 first, which gives me 2 times 16 is 32 times 3.14 plus 56 times 3.14. Now I can multiply each one, or I can just put everything in the calculator, but I'm going to multiply each one first and the addition last. So 32 times 3.14 gives me 100.48 plus 56 times 3.14 equals 175.84, and I add that plus that. So 175.84 plus 100.48. And so the surface area is equals to 276.32 square centimeters. Square because it's area. Any type of area is going to be square. And so in here we have from square to cubic. Remember that the first steps is to divide big by small. And this is not using proportions. It's an indirectly way of doing it, but not really. So we're going to divide the big by the small of what we have. And that's the first step. The second step is we're either gonna take the square root or cubic root, or we're going to raise to the second power or the third power, depending on what we have, okay? So in the third step is to either multiply the small one times whatever we get from answer 2, or we get the big one divided by the answer that we get in here. So it all depends on what figure. Since you have seen this lesson right now, if you haven't seen the lesson, it's gonna be confusing, but if you saw the lesson, then this will make sense. Okay, so in here, what they gave us is the two areas, but we're missing one of the cubes, okay, or the volume. So the first thing is to divide the big one by the small one. So 25 divided by 1, that's gonna give me 25. But that's area. And we wanted to get it to the length, right? It always goes back, whether they give us volumes or they give us two squares, we need to bring it back to length. Okay, this is very important when we have the two comparing or proportions with areas and volumes. For the length, since this is area, we cancel the square by taking the square root. And so for the length is going to be 5. Okay. Now, from length to volume, we raise to the third power because that's what we're missing. So it's going to be 5 cubed, and 5 times 5 equals 25 times 5 is 125. This is the number that we're going to be using. The third step is to, since we have the information for the small times that number. So 1 multiplied by 125 gives me that x is equals to 125 cubic centimeters. Okay. And this again is only because we're doing from area to volume, or when we're doing from volume to area, that will, like, this is the extra step that you have to take. I should have written it in a separate piece of paper. So big divided by small, that's the first step. The second step is to either, well, let's look at this one specifically. Since we have from lengths to cubes, we're going to either raise it to the third power or take the square root, this cubic root of whatever they're giving us. And I'll show you in a minute how to identify what to do, this one or this one. The third is, again, small multiplied by whatever number we get in here, or big divided by the number that we get in step 2. Okay, first step, divide big by small. We don't have the volumes, we have two lengths. So we're going to divide 3 by 2. And that gives us 1.5. You can use your calculator if you're not sure. 3 divided by 2. Or you can leave it as a fraction, which is 3/2. So that's my comparison between these two, or my ratio. 3 divided by 2. In here, we don't have the cube. We're going to raise this to the third power. And that's how you identify it. In the two numbers that we have, the two measurements, if we don't have that, we're going to put the 3. So in here, we're going to raise it to the third power. So it's going to be 3 times 3 times 3, which gives me 27, divided by 2 times 2 times 2, which is 8. Some people prefer to use the decimals. That's fine. You're raising to the third power, and you just put it in here. And your calculator is y to the x. You just press that, 1.5 to the third power, and it gives you 3.375. Okay, so when you raise that to the third power, the answer is 3.375. And so I'm gonna put it in here. The answer from this is, and actually if you think about it, look at this, 27 divided by 8 is a 3.375. So that's the number that you're going to use here. You can use it as a fraction, it's up to you, 3.375. Now the third step says, if you have the small one, you're going to multiply the answer that you, or the measurement that you have, times that number. But if you were given the big one, then you're going to divide. Okay, in this case, we have the small measurement, so we're going to multiply. And so we have that answer already. We just multiply it by 16, which gives us the answer of 54. So x is equals to 54 cubic centimeters. Okay, so for number 7, same steps. So I'm just gonna look in here. The only difference is that because we're looking at areas, this is not gonna be cube it or take this the cubic root. It's going to be square it or take the square root. Okay, so the second step is going to change to square it or take the square root. So let's do the first step. Divide big by the small one. So we have 30 and 20. So 30 divided by 20 is equals to 3/2. Why? Because both are divisible by 10. And if you prefer decimals, you're going to put as 1.5 again, right? 3/2. Okay, what do I have? It's the length. If you don't have a square in here, then put it in here. Square this. Okay, look at what I'm saying again. If on what you are dividing you do not have the square, you put it on. But if what you have is the squares, you take the square root to cancel it. Okay, we'll see it with the next example for that part. But again, these don't have the square, you square it to find the other number. So if you decide to use the fraction, it's 3/2. Square that is equals to 3 times 3 is 9. 3 times 3 is 9. And 2 times 2 is 4. So now what do I have? The big one or the small one? I notice that I have the bigger, looking at this is the bigger number. So I have the big one, so I'm going to divide. And that means that I'm going to put 3, the big number, which is 360. And I'm going to divide by the answer of the second step, which is 0.5. And you're going to square it, not cube it, square it because we're talking about area. So square it. And the answer is 2.25. And so that's from step 2. That's what I'm going to divide by. So 360 divided by 2.25. In here we have to follow the order because division is not commutative nor associative, okay? You have to follow that order. So I erase it, and I get 360 divided by 2.25, and the answer is 160 square centimeters, because we're talking about square in here. Okay, so that's the value of x. X is equals to 160 square centimeters divided by small. And the second step is, because it's a square, it's areas, so we're going to either take raise to the second power, or we're going to take the square root. Square because it doesn't, it's areas, okay? And the third step is to get the small and multiply by the answer we get from step 2, or get the big one and divide by the answer that we get in step 2. First step, divide big by small. The big one is 100 divided by the small one is 81. We cannot do these ones because this doesn't have the answer or the measurement. Okay, so in here, look at what we're gonna do. What we're comparing is the areas. That will be the answer here when we divide. If you have the square, cancel it. If we didn't have it, we put it, right? To get the other number. But in here, if you have it, you have to cancel it. How do you cancel a square? Well, you take the square root. That's how you find when to use the square, when to use the square root. If you have the square, you cancel it with the square root. That's when you use the square root. And what do we get? Well, the square root of 100 is 10. The square root of 81 is 9. That's the answer for step 2. Now, somebody asked me, teacher, what if I decided to use decimals? That's fine. Our answers are going to differ a little bit by some decimals, but let's do that. 100 divided by 81. 100 divided by 81. You get 1.23456, and then it changes. 1.234, etc. The more numbers you use, the more accurate or closer to mine your answer will be. Okay, so this is this. Then what do we do with that 100 over 80? We take the square root. So the square root of that is 1.11111. Just put. So in here, it will be 1.11111. In fact, 10, the square root of 10 divided by 9. Okay, I already got the answer either in decimal form or just in fraction form. Since we got the square, we take the square root. And we got 1.11111. What do we do for step 3? This is the big shape. This is the small shape, which is what we have. So what are we going to do? If we get the small, we are going to multiply. So we're going to multiply 9 times 1.11111. Okay? And that times 9 gives me 10. So the answer is 10 centimeters for x. Now, what if you decide to use 10 over 9? Well, let me use it in here. Then it's going to be 9 times 10 over 9. We put it over 1. We multiply straight, and so 9 times 10 is 90. 1 times 9 is 9. And 90 divided by 9 is 10. So if you notice, you get the same answer. Okay. So if you were not here for this lesson, this is going to be a little confusing, but I hope that this, if you were here, then it clarifies any last doubts that you have. Again, how do you decide which step to take here? I think that's the biggest confusion. if you have, in the ones that you divided, here, if you have either the square or the cube, if you're talking about volumes, you take this step to cancel that. But if what you have is, let's say that you had this instead, lineal, then you put the 2, you square that, okay? You divide that, and then you square it. If you don't have the square, you square it. If you have the square, then you take the square root. Same for the volumes. Let's see. If you don't have the cube, you cube it. But if you do have the cube, then you would have taken the cubic root, okay? You cancel this if you have it. But since you don't have it, then you cube, or raise that to the cube. In here, you don't have it, then that's why you're squaring it. So hopefully that clarifies, because I think that's the step that is more confusing. Once you find that number, then you just either multiply if you have the small measurement, or divide if you have the big measurement.